In this lesson, we're going to discuss data redundancy. Now, one of the most effective ways to create data redundancy is to use a RAID. A RAID is a redundant array of independent disks, which allows an organization to combine multiple physical storage devices into a single logical storage device that's recognized by your operating system. There are many types of RAIDs out there, but the most common ones and most popular ones we're going to discuss are RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10, also known as RAID 10. First, we have a RAID 0. A RAID 0 provides data striping across multiple disks, and it's used to increase your performance. The key word that you need to remember for a RAID 0 is striping. Now, a RAID 0 should be used when you need performance, but you don't really care about fault tolerance. In fact, a RAID 0 is the only kind of RAID that does not provide you with any kind of data redundancy, but instead, it provides us with faster read and write speeds because your data is being split across multiple drives inside of that RAID to overcome the physical speed limitations of traditional hard disk drives and other slower storage devices. For example, if I was building a high-end video editing workstation, I might want to use a RAID 0 to have two hard disk drives working together so I could work on my raw video files faster than I could by using a single hard disk drive. To create a RAID 0, you need to have at least two disks that can be configured to work in tandem with each other. Second, we have a RAID 1. Now, a RAID 1 is going to be used to provide redundancy by mirroring your data identically onto two hard disk drives or solid-state devices. This way, if one of those storage devices fails, the other one can continue to operate because it has a full copy of everything that was included on those drives. The key word you need to remember for a RAID 1 is mirroring. Now, a RAID 1 provides the least amount of downtime because there's always a complete copy of your data ready at a moment's notice that can be served up to your end users. A RAID 1 is going to provide us with some great fault tolerance, but it can only be used with two physical storage devices, which in turn only provides you with one single logical storage device that can be read or written to by the operating system. For a RAID 1, you can only lose one storage device and still be able to operate the array without suffering from any data loss or downtime. For example, on that high-end video editing workstation I mentioned, I might also want to add two other physical storage devices that are configured as a RAID 1. This way, I can use that to store all of my finished videos on. This will ensure that I always have an online and on-demand backup ready in case one of my storage devices fails, because both devices will have a fully mirrored identical copy of the data on them. Third, we have a RAID 5. Now, a RAID 5 is known as a striping disk with parity, and it requires the use of at least three physical storage devices in order for it to work. A RAID 5 will provide us with fault tolerance by striping the data across multiple physical storage devices, as well as writing the parity data across the disk array. The keywords that you need to remember for a RAID 5 is striping with parity. Now, if one disk fails, the other two are going to be able to reconstruct the data based on the parity, and that way they can continue their normal operations, but at a slower speed because the missing portions of data have to be calculated on the fly when the user is requesting the data from the server. So, if one of those drives fails, you can actually remove the failed drive, install a new drive into the server while the server continues to operate, which we call a hot swap, and then the server will rebuild the missing data onto the newly installed drive by calculating all those missing pieces by using the striped data pieces and the parity to calculate the missing data set. Now, for a RAID 5, you can only lose one storage device and still be able to rebuild the data in the RAID without suffering from any downtime, so keep that in mind too. Fourth, we have a RAID 6. Now, a RAID 6 is a modified form of a RAID 5 that relies on the use of data striping across multiple storage devices like a RAID 5 does, but instead of having a single piece of parity data, we're actually going to have two identical pieces of parity data. I like to joke around and say that RAID 6 is one better than RAID 5, so instead of having one set of parity, we now have two sets of parity because it is one more than RAID 5. Now, to achieve this double parity, your RAID must have at least four storage devices contained within your RAID 6 array. Now, the benefit of using a RAID 6 over a RAID 5 is that you can now lose two of your storage devices and still be able to rebuild the data without suffering from any downtime. So it does give you some more resiliency and redundancy. Now, the keywords you need to remember for a RAID 6 is striping with double parity. Fifth, we have a RAID 10, also known as a RAID 10. Now, a RAID 10 or a RAID 10 will combine the advantages of a RAID 1 and a RAID 0 into a single RAID array. Essentially, a RAID 10 is going to be a striped array that contains two sets of mirrored arrays within it. This is why we call it a RAID 10, because it first mirrors the two sets of storage devices into a RAID 1, and then it stripes the data across both sets of mirrored storage devices using a RAID 0 configuration. So, RAID 1 plus RAID 0 gives us RAID 10 or RAID 10 as we write it out. Now, the keywords you need to remember for a RAID 10 is that it is a striped array of mirrored arrays. Now, a RAID 10 or RAID 10 also supports the use of even numbers of physical storage devices to create this kind of an array. And you have to have at least 4 physical storage devices in the RAID to create a minimum of 2 sets of mirrored RAID 1s to be able to use inside of your RAID 10. A RAID 10 will provide us with fault tolerance due to the mirrored arrays inside of the RAID 10, but it also provides us with faster speeds because of the striping of the data across 2 different sets of mirrored arrays inside of the RAID 10. Now, a RAID 10 can support the loss of up to 2 of your storage devices and still be able to rebuild the data without suffering from any downtime, as long as the loss of the storage devices are not both located in the same mirrored array. So, if you lose one storage device from each mirrored set, that's fine. The RAID 10 will continue to operate without any issues, but you will have lost your fault tolerance capability if you lost a drive from each set of the mirrors, so you'll want to replace those failed storage devices as soon as possible. Now, when we talk about the classification and categorization of our RAIDs, we call these either failure-resistant, fault-tolerant, or disaster-tolerant. Each of these terms describes a level of resilience that a RAID system can provide against data loss and system downtime. When we're dealing with failure-resistant systems, these are systems that are designed to withstand certain hardware malfunctions without losing the associated data, and failure resistance is going to be achieved through redundancy of your storage devices by mirroring data across multiple storage devices. This means that if one device fails, the system can continue to operate using the data on the remaining devices. So, when you think about a failure-resistant system, we're really talking about any of the systems that use mirroring, which is a RAID 1 or a RAID 10 known as a RAID 10. Now, a fault-tolerant system, on the other hand, is going to be designed to not only allow for the continued operation without any downtime being experienced, but also allows the system to maintain its operations in the event of a hardware failure due to either mirroring or striping with parity, such as in a RAID 1, RAID 5, RAID 6, or RAID 10. With fault-tolerant systems, your system has the ability to quickly rebuild any lost data from the remaining healthy storage devices to ensure your systems remain resilient. Now, a disaster-tolerant system includes a broader level of protection by safeguarding your data against catastrophic events. Disaster-tolerant RAIDs utilize 2 independent zones that always have full access to all of the data. A RAID 1 and a RAID 10 are both examples of disaster-tolerant RAIDs because they have full mirrors of the data on at least one of the storage devices within the array. So remember, RAIDs are a great thing to use when you're trying to ensure you have a good redundancy of your data, both online and available at all times. A RAID is a redundant array of independent disks, which allows an organization to combine multiple physical storage devices into a single logical storage device that is recognized by your operating system. A RAID 0 is going to enhance the performance by striping your data evenly across 2 or more storage devices without any kind of redundancy to facilitate a high-speed access, but you're not going to have any fault tolerance. A RAID 1 is going to maintain an exact copy of the data, which is known as a mirror, on 2 or more storage devices to increase your read performance and ensure data integrity and availability even if a single storage device in the RAID fails. A RAID 5 is going to distribute data and parity information across 3 or more disks to improve the read and write performance while also providing fault tolerance. A RAID 6 is similar to a RAID 5, but it adds an extra parity block so that the data and double parity is going to be striped across 4 or more storage devices to help withstand the failure of 2 storage devices simultaneously without having any kind of data loss. A RAID 10 or a RAID 10 will combine the advantages of a RAID 1 and a RAID 0 by striping data across mirrored sets of storage devices to offer higher performance, fault tolerance, and improved data redundancy. By relying on the use of RAIDs, we can increase our overall availability when we're designing high availability systems for our enterprise networks.